Hey guys, welcome back. Here is a brand new series we're going to start, which is about weights in Selenium. So what is weight? To make it very easy concept about the weight, it is like example, here is everything we see in a web application. It's called, element or web element or web object. So example, the LinkedIn profile is in one web object. And, what do? We inspect or spy this element and find the locator. And then, we write our code like driver.find element, whatever the locator we like example, we use XPath. Then we apply an action like a click action, right? So this web element like LinkedIn profile, this object, it has its own speed to load this object through this web application. So every object in this application, it has its own speed to load it. That's number one things to remember. And there is another things like, who exactly, inspect or read our code. That's our web driver. Web driver, read our code and navigate to the browser, and it's follow the instruction and follow the command like, find this, follow the path, XPath or locator for this element and apply the action. So that the web driver, the driver we use, it has its own speed too. So when the speed between the driver and also this object of the web object or web element doesn't match, have some synchronization issue, the speed doesn't match, that time we get some sort of error, like it's called element not found or elements not visible exception. So to avoid this kind of error, Selenium, it has its own features or libraries called weights. So there is two weights you can find in Selenium. One is called implicit weight, another one is called explicit weight. And an explicit weight, it is like two part. It has one is web driver weight, another one is called fluent weight. So let's see what is explicitly weight. So explicitly weight in Selenium is used to tell the web driver to wait for a certain amount of time before it's through and no such element exception. The default settings is 0 seconds. Once we set the time, the web driver will wait for any element. When we use like driver.find element method, on that find element method will applicable the weight we're going to set, the implicitly weight. And since till then, if the driver cannot find that element, then it will throw the exception. So implicitly weight, also it's called global weight. So let's say syntax. So syntax is called timeouts, like driver.find out timeouts implicitly weight, and then you'll use the duration, one of the a signature or parameter. Then there will be other part of the parameter of seconds, like 10 seconds, 5 seconds, whatever you want to apply. Let's go to our Eclipse. So here is our Eclipse. Let's create one class. We'll give a name, say weights exercise. Weights exercise, okay, public, and let's use our common code. Okay, let's use this two part. So Chrome driver object, and puts in a reference is driver. Web driver is our return types, and maximize the window. Okay, and then we can use let's use we're going to use driver dot get. We're going to use in this exercise, we're going to use google.com. Okay, so we're going to use google.com. Okay, google.com. So here let's go to google.com. So we're going to spy the search box here. Okay, let's spy it. And then here you can see the different parameters it has, or attribute it has. Let's see which one is the easiest one. I think name. Okay, we can use name. You can see, all right, we can see the name. You can see the name. It has a name attribute, so we're going to use the name attribute. Let's copy the QA. Okay, and we'll say driver dot find element by name. Okay, name. And what's the value of the name? Name is 2. So this is the value of the name, and then we're going to type up there. Let's type something up there. So we're going to type here, let's type Codenbox. Okay, so that's what we want to type, Codenbox. So to type something, we're going to say send keys, right? Send keys, and then we're going to type here Codenbox, box, and then let's, after we type over here Codenbox, then we want to hit enter. Okay, so that there is a result comes up over here. So we want to hit enter. To hit enter, we have learned in one of our previous exercise where we have seen the use case of keyboard. To hit enter, we can pass keys dot, you can see enter. Okay, you can see enter over here, enter. Okay, you can see here, sorry, enter. You can see enter. There is enter. Okay, enter. So keys dot enter will hit enter. Okay, so that's about okay, and after that we're going to use, let's let's run it. Save it, Control S, then let's run it. Run the application. It was very quick. You can see that it started, it's type, and then it's hit enter. That's why it's came to this pages. Okay, so it was very quick. So now we're going to use implicitly wait. Okay, implicit. So if I want to use implicitly wait over here, we have to, let's see, go back to our node. So implicitly wait, this is the syntax of the implicitly wait. So we're going to say driver.manage.timeout implicitly wait, and then you will apply that wait. Let's go there. So if you want to add the implicitly wait, so we have to add before it's launch our applications right here. So we'll say, hey driver, we'll say, hey driver, driver.manage, manage what do you want to manage? I want to manage timeout about what timeout is implicitly. You can say implicitly wait, and then there is a 2 parameter duration. Okay, so, and here you will type duration dot, then you can see the duration, what parameter the unit you want to pass for duration, the seconds, nanoseconds, hours, days. So I will pass the of seconds. How long seconds? I would say 10 seconds. Okay, so this is the syntax of implicitly wait, and this is implicitly wait. It's also called global wait. It means this 10 seconds will apply each and everywhere where we're using a find element method. So wherever we're using a find elements method, this 10 seconds will apply. But this is the max 10 seconds to before. So so example here is we're using a find elements, to find an element using a parameter or attribute called QA. If this elements loaded before this 10 seconds, so this 10 seconds will apply over here, but if this element loaded before this 10 seconds, this will not, this implicitly wait, this wait will not fulfill or wait until to finish this 10 seconds. So example, this element loaded within 2 seconds, this implicit wait will not wait to finish this 10 seconds. It will move on the next the next element or next script. So this is the one of the benefit for using the wait or implicitly wait from Selenium. This is the default behavior for any waits that we use from Selenium library. Okay, it will not wait until the time it's declared. If the elements appear before that time, it will move on to the next element or next script. Okay, next line of your code. But this is a global wait. So anywhere we are going to use find element, this wait will apply before it throws any error. Okay, so this is that's all pretty much the implicitly wait. So we can say here, this is let's put it node over here. So we are saying implicit wait. Okay, implicit wait. Let's go over here, and similarly implicitly wait, it has some more use case, like you can add another line. It's called page load timeout. Here is another implicitly wait, which is the script timeout. So script timeout is nothing that the script we write, it takes time to load also. So, and if the script some reason takes time to load, and then it will throw an exception because your script is not executable until it's loaded. So you can set some time to load your script, as well as you can set time to load your page. So whole page. So you can put also, those are all global wait. Okay, so you can add also over here to page load timeout. Okay, duration of say 10 seconds. So this 10 seconds will apply to find elements whenever it's going to be use any find elements method. But here is a 10 second. This will apply to your entire page to load the whole google.com. So sometimes especially some e-commerce side, because it's heavily loaded side, and it takes time to load all the elements. So if your elements, if your driver is looking for whatever the elements, and if his element is not loaded yet, this will apply. And even 10 seconds later, if it's not loaded, then this 10 seconds will apply, because before it throws any error, because this 10 seconds is applied to entire page. Okay, to load, this is another global wait to load your page to entire page, then it will throw an exception. Okay, so that's all for the implicitly wait. Hey guys, now we're going to see explicit wait. So what is explicit wait? It is used to tell the web driver to wait for certain condition. Expected condition or maximum time exceeds before throwing element not visible or element not found, that exception. It applied only for a specified web element instead of waiting for all the statement in the program. So it gives a better option than implicit wait, as it's wait for dynamically loaded Ajax elements. It is also known as local wait. So overall, the explicit wait is a local wait. So after we apply implicitly wait, say you have 10 seconds, and still the elements didn't find, that time, or we got an error, that time we can apply or include a explicit wait or any local wait to a specific element for a specific element before it's throwing an exception. Okay, so here is the syntax. we have to use object of new web driver with, then there will be two parameter, driver and duration of seconds. Okay, and then we can use this object reference with. So one of the method, it's until, then we can use expected condition, and then underneath it has a lot of other methods like visibility of elements, visibility elements to click, and you will see. Okay, let's go to our Eclipse. So here is the same class we're going to use that we use for our last exercise, like for implicitly wait. So here we're going to, let's make a note here. We're going to do that out explicit wait. Explicit wait. Okay, so in the explicit wait, we're going to do let's create an object how to declare the explicit wait. To declare explicit wait, we're going to use new, then we'll create an object of it. The class is called WebDriver wait. Okay, if you see here, the WebDriver wait. Okay, so this is the new, create an object for WebDriver wait, and after that, let's put this one in a variable. Let's put a variable, it's called a wait object reference, and the return type would be WebDriver wait, right? WebDriver wait. Let's hover our mouse here. It's, you have to import the package, related package. Okay, and then it's throwing error. So let's hover again. So it shows add argument to match WebDriver. Okay, so we have to add this argument, WebDriver and duration, right? Let's put this WebDriver. We're going to say, so WebDriver is like our driver, the object of our WebDriver. The object reference of our WebDriver is a driver. So, and then here you have to pass how long, the duration. Okay, duration of seconds. Duration dot, and then of seconds. If you're not able to see this option, just hit Control and Shift. You will see those drop down option. All related method will show you. Okay, this is, so let's select the of seconds. So let's use the, I would say 8 seconds. So this is a local wait for specifically one element. So I will put in like a little bit less than our global wait. Okay, 8 seconds. Now this wait is an object reference of this class, is for this object. So in this WebDriver wait class, it is a lots of method. So we can call those method. Let's call in one method, right? Using this object reference, so wait dot, then you can see, there's a lots of method. We can use until. Let's use until. So we're going to say, wait until about what? Until for, until what? Until we'll say expected condition. Expected conditions. Okay, and then control space, you can see, okay, expected condition, then let's expected conditions, and then expected condition dot, and as soon as you put the dot, you can see there's a lots of other method that comes from the expected condition. You can see element to be clicked, element to be clickable, element to be selected, lots of others. Even visible, you will find visible of elements, you will find all those things. Let's use the element to be clickable. Okay, element to be clickable, element to be clickable or available. Let's see, let me show you. Sorry, dot element to be clickable. Okay, clickable. So element to be clickable, and here what do you want to do? We want to, let's go here. So after we in our last exercise we wrote this in our Google search Codenbox, and then it shows this, right? So we want to we want to click on this Codenbox, that link. Okay, that's what we want to do. Okay, to do this, let's right click, let's inspect this element, and here we can find this is the HTML related code for this the Codenbox. Let's use our selector sum. It's going to be easier for us. Okay, let's use XPath. So this is the XPath. This is the XPath. You can see. Okay, and then let's copy this one. Go back to over here. So we're saying that expected condition. Let me make it a little bit bigger. Expected condition, element to be clickable. What element? So this is the element to be clickable by dot XPath. Okay, XPath, and then here is the locator of the the Codenbox link or this element. So we're saying that wait until expected conditions. The condition, you have to wait until the element to be clickable, this element. And what element? This element until it's clickable. Wait until that, and at least the 8 seconds. And how long? It will be 8 seconds. Okay, so this is the one, and let's put this one. We'll put this statement, this one. This is a locator, right? Web element, right? So let's put this one in a variable. It's called, let's give a name, Codenbox. So I will say Codenbox link. Okay, and it's a the return type would be web element. Okay, hover mouse, import and related. So Codenbox link, this is the variable. It has the knowledge about this locator, right? And then if I say Codenbox link, then dot click, right? Click. So it will click up there. That should click up there. Okay, so let's save it and run it. So I'm going to run both together. Our from our last class is implicitly wait, and over here explicitly wait. Okay, let's save it, run Java application. You can say it's clicked, and then it's loaded to our codenbox.com. Okay, let's close it. If you want, you can add at the end, driver.quit. That's fine. Driver.quit. Okay, so that's all about the explicit wait. Just one important information about the explicit wait. It has a polling frequency is 500 milliseconds. Both in explicitly and implicitly wait, they have a default, polling frequency is 500 milliseconds. Okay, that's very one important information. Okay, so that's all for the explicit wait. Hey guys, welcome back. So in this lecture, we're going to see how to apply fluent wait in Selenium. So it is used to define maximum time for the web driver to wait for a condition, as well as the frequency with which we want to check the condition before throwing an exception. So it's similar like explicitly wait. It's another part of the you can say another wings of the explicitly wait. So it checks for the web element for a regular interval until the object is found or timeout happen. So this is the difference between the explicitly wait and fluent. It checks the web element at a regular interval before it's throwing an exception. Okay, let's consider a scenario where as an element it's loaded at different interval of time. It's happened in the e-commerce site very frequently that it's loaded the element with a different interval of time. the element might load within, say, example, 10 seconds, 20 seconds, or even more than if we declare an explicitly wait of 20 seconds. So it will wait till the specified the time before throwing exception. In such scenario, the fluent wait is the best option to use, as this will try to find the element at different frequency until it find it, or the final timer runs out. Okay, so the big difference that it check the element at regular intervals. Here is a syntax. So there's a fluent wait class, so we have to create an object of fluent wait class, and then it has a parameter like web driver, and the driver object is the driver, and then this is the object reference of the new fluent wait or fluent object, and also the return type would be web driver, and the type is data type is wait, or the object type is wait. Okay, if you want, you can just copy this one, or you can write it. So let's go back to our Eclipse. I'm going to make a comment for this one, for driver.quit. So here we're saying this is about fluent wait. Okay, so we're going to create an you can create an object of new fluent wait. Okay, and then the object of the web driver, the object is web driver, the parameter, and then the object reference of a web driver, it's driver, and then let's put this object of this fluent wait in a variable, or you can say let's put a fluent wait. This is the object reference of this fluent wait object, and then type and return type would be exactly the same, like web driver would be the type, and the element type is the web driver, and this class is the return type is it's a wait. Okay, then hover your mouse, so import the package. Okay, hover again, import the package related with the wait class. Okay, and after that you can say here it has, so we created an object of fluent wait, right? So now we can add more parameter with that. So let's put in dot, and then we can say we can add with timeout. You can see there's a timeout and there's a duration timeout. So we're with timeout for how long? Duration dot, again, of seconds, select of seconds. How long? So let's say again 10 seconds. Okay, with timeout is 10 seconds, and with that we can add more argument like pulling every, you can see. So this is the one of the difference between the fluent and the explicitly wait is pulling. So it's give you the option for the interval to check the element with the interval time. So here is a pulling every. So what would be the pulling every? Let's add this pulling every. Duration dot of seconds. How long? Let's say 5 seconds or 2 seconds. Okay, and then you can even add, you can say let's go to our node. So we added with timeout, So this is the timeout we added, and then we can add it with a more argument, which is pulling every the timeout 5 seconds or 2 seconds I added. And then also you can add ignoring. So ignoring, so it can ignore specific so when it doesn't find the element, it's throw an exception like no such element exception. So we can ignore that exception, like no such element exception class. We can ignore that too. So let's copy this one, so we can add over here dot ignoring. You can see there is a ignoring all, so it can pass no such element exception dot. It's a class, right? So it is a class of the no such element exception is a class, so we can ignore even that class. So all these 3 different argument that goes with the fluid weight. It is a local weight, so you can apply this weight. You can apply this weight now. So this is the declaration of the weight. Now you can use this object reference of the fluid weight dot. You can say until, similarly we use implicitly weight, like explicitly weight we use until over here, right? Wait until. So similarly we can use dot until, then we can use exactly the similar expected condition until our one condition is expected condition dot element, same element. You can say element to be selected, to be clickable. Let's select to be selected. We can pass the to be selected and the locator of that element. What would be the locator? Let's put the same locator, same object. Okay, for XPath for the same object. Let's copy this, and then here we'll say by dot XPath. Okay, and the value of the XPath. Okay, so the same way, and then you can put exactly the same way this same locator in a variable, then use this variable with a click. So it is an alternative. Fluid weight is an alternative of explicit weight. So either you can use explicit weight or fluid weight. Okay, the benefit of fluid weight, it has a pulling every option, the duration, pulling every duration of, say example 5 seconds, so that if there is a elements loaded with the interval duration, so that time you can add the fluid weight. It will be better option to use the fluid weight than explicit weight. Okay, so that's pretty much the use case of the fluid weight. There is just one more thing I want to add. We always see, frequently we use thread.sleeps, right? Thread.sleep. Long, say example 3 milliseconds, 3000 milliseconds. So then what about the thread.sleeps? So you have to add the add through declaration. You can see this thread.sleeps doesn't shows any package. So because thread.sleeps, it's not part of the Selenium library. It comes from the Java. So that's why you have to add this thread.sleeps as an exception. You can see as an add through declaration. You can see it's an interrupted exception. You can see. So how this thread.sleeps used? So this is thread.sleeps also considered as a local weight, but it is an unconditional weight. Unconditional weight. It comes from the Java. So how it works when you use thread.sleeps, for example 3000 milliseconds, it means 3 seconds, it will hold, this thread.sleeps will hold your entire execution, our script, for 3 seconds. So it will work on the script, not on the element. So it will hold our execution for 3 seconds, and in the meanwhile, if that element is loaded on the page or found, then it will able to find it, or otherwise it will throw an exception. So And here is a big difference using between the threaded slips or fluid wait or explicitly wait. The explicitly wait or fluid wait, it works in such a way. Say we uses the timeout for 10 seconds. If the elements appears like 3 seconds, within 3 seconds, our driver will not wait to complete this 10 seconds. It will move, it will right away, it will move to the next line of the execution. But thread to slips, it will, no matter what, even the elements loaded before 3 seconds, still the execution, it will wait for 3 seconds, because this thread to slips is holding our script, this script, not the element. So it will complete the waiting period, waiting time, and then it will enable to execute the code or enable to find work on the application through the driver. Okay, so that's why it's not a good practice to use always thread to slips, because if you use thread to slips, say example 10 different times, 10 times in one class, it means, and every time is 3 seconds, so it means 30 seconds. No matter what, even its element appear before your 3 seconds, but still your script will be wait 30 seconds. So each and every class, if you use 10 thread to slips and wait 30 seconds, so in real life you have to write hundreds of class. So your execution is going to be really slow down, and it will be a big question for performance. So you can use once in a while, but it's not a good practice to always use the thread to slips, other than use the explicit wait or fluent wait. Okay, that's all about the the synchronization in Selenium or waits in Selenium.